In this tutorial, we are familiarizing ourselves with the Supervised Red tool. We will do this through a texture inspection. The first step is to add the Red tool, and then add the images. Here are all of the images, and you can see that they are named in a specific way. Some images contain the word bad in the file name. This is how they are distinguished from the good images. Here we have good and bad images. The good images are named with just the number, where the bad images contain the word bad. And they are easily found by typing bad in the search field. Here we have all of the bad images. We want all of the images, so we can select one and Control-A and open to select the images. Next, we select the ROI, the region of interest. By default, the whole image is selected. And we can apply. Now we need to label the images, either good or bad. First, we can set all of the images as good images, and then we need to find the bad images. In the display bar, enter single quote, bad, single quote. And now we have all of the images with file names that contain the word bad. Actions for these images: label views as bad. Now we can have a first look at the performance of the unsupervised Red tool. We can train the software, then there will be time for processing, and we can observe the first set of results. The results of the training and processing are shown on the right side bar. We notice that there are a large number of images that are misclassified. Even if we move the thresholds closer to one another, we still have many misclassified images. And we can also see on the views that the defects are not recognized by the tool. On this image, for example, the defect that we want to see is on the top left corner. But the actual defect is not recognized. In order to solve this problem, we need to set the tool to supervised. This means that we need to label the bad images. We need to edit regions on these bad images in order to show the software what the defects are. So we right-click, Edit Regions, and then we have several tools for painting the defects. We can use this line tool and change the width, for example, depending on the size of the defect we want to label. And then we paint on every region. Click Apply. We should edit regions on at least 50 images. There will be a portion that will be used for training, while the other portion cannot be used for training. So now we have labeled the majority of our images, about 60 images in total. We can now adjust the parameters before training. For the feature size, the default size of 40 is appropriate for the defect size that we want to find. Some of the defects are smaller than this one, so it appears to be the correct size. Color channel is 1 because our image is in black and white. The epochs is the number of times the image set is shown to the software. So for particularly complex images, we want to have a higher number of epochs. In our case, for example, we can set it to 75. It is a bit larger than the minimum, which is often set to 50. The maximum number of epochs could be as high as 150, with the highest number set to 200. Train selection can be left at 50% because we have 60 images, so we will train on 30 images for the defects and also save 50% of the good images for training. In the perturbation, we can add flip, which is both horizontal and vertical. Because we see that this image can be inverted either horizontally or vertically, and this will not change the appearance of the defects or the appearance of a good image compared to a bad image. Luminance can also be modified. As you can see, if we set it to a high number, for example 30, it is the brightness of the image that you see in this animation. It is appropriate in our case because you see that the image does not have the overall luminance, so some parts of the image are brighter and clearer, while other parts are darker. Let's set it to 5% because if it's too big, it could actually reduce the performance. And contrast can also be set to 5%. The difference between luminance and contrast is in the brightness between clear and dark areas. For example, if we have the animation as an example, the letter F becomes practically invisible when the surrounding area becomes very dark. Let's set it to 5%, and now we can train. Now, after the training and processing, we obtain a good classification of good and bad images. We see that even if we move the thresholds far apart from one another, there are no misclassified images. Labeling approximately 60 bad images, so editing regions on approximately 60 bad images does lead to good accuracy and good performance. We may be able to obtain these good results with fewer bad images with edited regions, but make sure that you remember to add the perturbations, which will improve the accuracy significantly.